विद्यार्थी मित्रों, सेकंड चॅप्टर आपण बघणार रियल नंबर्स. या चॅप्टर मध्ये द प्रॉपर्टीज ऑफ रॅशनल नंबर्स, प्रॉपर्टीज ऑफ इरॅशनल नंबर्स, सर्ट्स, comparisons of the quadratic surds, operations on the quadratic surds, rationalization of the quadratic surds. Now in the previous standard we learned about the natural numbers, integers and the real numbers. N is a set of the natural numbers, W is a set of whole numbers, I is a set of integers, capital Q the set of rational numbers and capital R the set of real numbers. Now in this case, that is their subsets. N is a subset of W, W is a set of I is subset of Q and Q is a subset of R. Order relation on the rational numbers, that is P upon Q and R upon S are the rational numbers where Q is positive, S is positive. If P into S is equals to Q into R, then P upon Q is equals to R upon S. If P into S is greater than Q into R, then P upon Q is greater than R upon S. If P into S is less than Q into R, then P upon Q is less than R upon S. Now let us some basic properties. That is a property, addition and the multiplication, commutative property. For the addition, A plus B is equals to B plus A. For the multiplication, A into B is equals to B into A. Associative property, that is in bracket A plus B plus C is equals to A plus in bracket B plus C. That is A into in bracket B plus C is equals to A into B bracket complete into C. Identity, A plus 0 is equals to 0 plus A is equals to A. A into 1 is equals to 1 into A is equals to A. Inverse property, that is A plus in bracket minus A is equals to 0. A into 1 upon A is equals to 1. Now decimal form of any rational number is either terminating or the non-terminating recurring type. Terminating means what? You have the complete division, that is the 2 by 4 is 0.4 minus 7 upon 64, 101 upon 8, these are the terminating type. And another, that is 17 upon 36, 33 upon 26, 56 upon 37, these are the non-terminating type. Because if the prime factors are 2 or 5, then it is a terminating type, and if the prime factors are other than 2 and 5, then it is a non-terminating or recurring type. To express the recurring decimal in P upon form, simple example, express the recurring decimal 0.777 in P upon Q form. Let x is equals to 0.77, that is 0.7 raised to dot. One digit is repeated, therefore multiply on both sides by 10. Therefore 10x is equals to 7.777, that is equals to 7.7 raised to dot. Therefore subtract 10x minus x is equals to 7.7 dot minus 0.7 dot. Then you will get x is equals to. Express the recurring decimal 7.529529529 in P upon Q form, and in this case the repetitions of the digits group is 5 to 9. Let multiply on both sides by 1000, then 1000 x is equals to 7529 dot 529. After multiplication and subtraction, you will get, that is a 999x is equals to 7522.0. Therefore x is equals to 7522 upon 999. Therefore the 7.529 recurring is equals to 7522 upon 999. Next, you can also solve Uh, Note the numbers of the recurring digit after the decimal point in the given rational number accordingly multiplied by the 10, 100. For example, in the 2.3 dot, then multiplied by the 10. If the two numbers are recurring, that is a 24 raised to bar, then multiplied by 100. And next, if the three digits are repeated, then multiplied by 1000. Notice the prime factors of the denominator of a rational number. If the prime factors are the 2 or 5 only, then the decimal expansion is a terminating. If the prime factors are other than 2 or 5 also, then the decimal expansion is a non-terminating and the recurring. Now we'll see the practice set 2.1. Now classify the decimal form of the given rational numbers into terminating and the non-terminating recurring type. Now just we have seen that if the denominator has a prime factors 2 or 5, then it is a terminating. The first is 13 upon 5 is a terminating. Next, 2 upon 11, the denominator is other than 2 or 5, therefore it is a non-terminating. Next, 29 upon 60, again if it make the factors of 16, that is a 2 into 2 into 2, that is a 4 times, therefore it is a terminating. Next, 17 upon 125, again it is a 5 into 5 into 5, it's a 3 times, therefore it is a terminating. And last, 11 upon 6, it is a 2 into 3, therefore it is a non-terminating. Now let's see, write the following rational number in the decimal form, that is a 127 upon 200. Now we can write this like this, that is a first 127 upon 200. Without division we can, that is 127, the 200 can be written as 2 into 100. 127 upon 2 into 100, that is equals to the division, then it will 63.5 and divided with the 100, then the 2 digits to the left hand side, 2 digits आपण डावीकडे येणार, that is 0.63.5, 0.635. Therefore 127 upon 200 is equals to 0.635. Next example, 25 upon 99. Therefore, we'll divide it 25 upon 25.00. Cannot divide with the division of the 0 first of all. Therefore, we have that is a 250. Next point, the division, that is a 2, it is a 198. The remainder is 52. Again the division. The division is the 5. That is, it will leave 495. Therefore, subtraction is 5, 12, 10, 2, and 0. Again, that is 25 upon 99 is equals to 0.25. It's a recurring. Next, (23 upon 7) first we'll divide with the 7. Therefore, the division of the first division is 3. 23 minus 21, then you will get the 2. Then point, the first 0. Second division, 20 minus 40. Then the remainder is 6. Again 0. 8th division another. 7 into 8, 56. 60 minus 56, 4. Again 1 0. Then the division of 5th division, that is 40 minus 35. You get, that is 5. Again 0. 7 into 7, that is 49. Therefore 1 is remainder. Again 1 0. The division of, या बाजूला डिव्हिजन करणार आपण आता. 10 first, 10 minus 7, that is a 3. Then it will become 30. Again the division of 4. Then the remainder is 2. And from this step, again the repetition is started. Therefore, we get the recurring type. Therefore, 23 upon 7, that is equals to 3.285714. Recurring. Now the next division. That is 4 upon 5. Now the denominator is 5 without division, that is multiplied n and d by 20. That is 80 upon 100. Therefore, we will get 0.8. Therefore, 4 upon 5 is equals to 0.8. Now the next example, that is a 17 upon 8. That is again the denominator is 8, therefore it is a terminating type, and we can write multiplied on numerator to the and denominator by 125. Then it is 2125 upon 1000. Therefore the answer is 2.125. Hence 17 upon 8 is equals to 2.125. Yes. Question number 2 is completed. Now question number 3. Write the following rational numbers in P upon Q form. Follow these steps. That is 0.6 recurring. Let x is equals to 0.6 recurring. It is written as 0.666. Equation number 1. Number that is 6 digit is repeated. Single digit is repeated. Therefore multiply on both sides by 10. Therefore we will get that the 10x is equals to 10 in bracket 0.666 dash dash. Therefore 10x is equals to 6.66666 recurring. This is equation number 2. Now equation number 2 minus 1. Then we will get 10x minus 1, that is equals to 0.66, that is 6.666 minus 0.666. That is 9x is equals to 6. Therefore x is equals to 6 upon 9, that is 2 upon 3. Next example, 0.37. Therefore 0.6 recurring is equals to 2 upon 3. Next 0.37. Let x is equals to 0.37. This is equation number 1. Now here 2 digits are repeated. Therefore we will multiply the both side by 100. Therefore x is equals to 0.373737 dash dash. Equation number 2. Multiply on both sides by multiply on both sides by 100. Therefore 100x is equals to 100 into in bracket 0.373737 dash dash, that is equals to 100x 37.373737 dash dash. This is number 3. Now again equation 3 minus 2. Equation 3 minus equation 1. Therefore 100x minus x is equals to 37.3737 dash dash minus 0.37 dash dash. Therefore we will get 99x is equals to 37. Therefore x is equals to 37 upon 99. X is equals to 37 upon 99. Now next example. That is 0.37 recurring is equals to 37 upon 99. Next, (0.37) recurring is equals to 37 upon 99. (3.17) recurring. Let x is equals to 3.17 recurring. That is x is equals to 3.171717 dash dash. This is equation number 1. Next, multiply on both sides by 100. Therefore, on both sides by 100. Multiply on both sides by 100. Therefore, 100x is equals to 100 in bracket 3.171717 dash dash. That is, you will get 100x is equals to 317.171717. This is equation number 2. Now equation number 2 minus 1. Equation 2 minus 1 is equals to 100x minus x is equals to 317.171717 minus 3.1717. Therefore, after subtraction, you will get 99x is equals to 314. Therefore, x is equals to 314 upon 99. Therefore, (3.17) recurring is equals to 314 upon 99. याचा अर्थ जेव्हा दोन डिजिट्स रिपीट होतात तेव्हा प्रत्येकदा डिनोमिनेटरला 99 असतो. नेक्स्ट 15.89 recurring, therefore x is equals to 15.89 recurring, that is x is equals to 15.89. This is one equation number 1. Multiply on both sides by 100 because the two digits are repeated. Two digits are repeated. Therefore, 100x is equals to 100 into in bracket 15.89 89 dash dash. Therefore, 100x is equals to 1589.8989 and dash dash. This is equation number 2. Now equation number 2 minus 1. That is equation 2 minus 1. That is 100x minus x is equals to 1589.8989 dash dash minus 15.89 dash dash. Therefore, after subtraction, you will get 99x is equals to 1574. Therefore, x is equals to 1574 upon 99. Therefore, 15.89 bar, that is a recurring, is equals to 1574 upon 99. 1574 upon 99. Now the next last example, that is a 2.514 recurring is equals to, let x is equals to 2.514 recurring. This is equation number 1. Multiply on both sides by 1000 because 3 digits are repeated. Both sides by 1000. Therefore, 1000x minus is equals to 1000 in bracket 2.514514 dash dash, that is equals to 1000x is equals to 2514.514514 dash dash. This is equation number 2. Now the subtraction. Equation 2 minus equation 1. Equation 2 minus equation 1. Therefore, you will get 1000x minus x is equals to 2514.514514 minus 2.514 recurring, and hence 999x is equals to 2512. Therefore, x is equals to 2512 upon 999. Therefore, 2.514 recurring is equals to 2512 upon 999. In this way, we have completed the practice set 2.1. Now we'll see the next practice set 2.2. Till then, goodbye.